All right. Today I'm going to talk about my project I'm working on, and this is a start of a 2x72 belt grinder that I'm making to help in my metal fabrication efforts. This will, really change how I work with metal today. A lot of stuff I do requires, using a angle grinder and a grinding wheel, and very rarely do I get the dimensions right on. I mean, as careful as I try, I always make some mistake and I get something off. And so I just needed some tooling that will help, make, more precision parts, touch up an end of of some tube steel, clean up the tube steel before I weld it. And this will help me a lot in that effort. The platen can be made square to the rest, and there's some good surface area. It has a good motor on its variable speed. So to start this project, I started looking online for ideas on how people made these things, and there's actually quite a few individuals out there making belt grinders like this. And one individual is this guy at housemade.us. His name's Brian House, and he actually sells plans. You can download the Fusion 360 plans, or you can buy printed plans. And he pretty much shows you how to build a 72-inch belt grinder from scratch. And of course, he also sells some prefabricated parts that you can buy if you don't have the means to cut these things out, which could probably save you a lot of time, but it's also very expensive. Probably, if you have access to a metal distributor, you can get most of the metal fairly cheap. It's just that you have to cut it out all yourself and drill all your own holes, which can be kind of hard to do if you don't have the right tooling for it. But, he has lots of YouTube videos on knife making, but also on his belt grinder. He talks about how he makes all the parts. So if you can stand to watch YouTube and all the commercials on it, you can check out all of his videos here, and highly encourage you, if you're looking to build your own belt grinder, to go this route. There is some alternatives too. There's this guy makes the Dictator Bandit. This is kind of a copy of Brian's, I think, um, and it's the same thing. It's a hinge design. Um, this grinder will rotate. Uh, it's it it can be a horizontal grinder or a vertical grinder, which is really kind of nice. Um, so like you can make a this rotates on the hinges here, and it can be horizontal in orientation or vertical in orientation, which gives you a lot of flexibility in your fabrication efforts. So, without further ado, I'm going to start talking about the changes I made to this design and the reasons I made these changes. And I'm not going to go into how to build his grinder. He does a really good job at explaining that. I'm just going to go into some of the changes I made and the modifications and the reasons why I made the modifications that I did. It's just some considerations to make when you go through this build process. Um, so let's get into it. All right. The first changes that I made to this was that I did not like how these hinge mechanisms were kind of an odd shape, which probably works well if you're using a laser cutter. But I was not using a laser cutter. I have a milling machine and a lathe, but I have no way of cutting these out, and I have no way of grinding these with any sort of precision because I don't have a belt grinder to do that work. So what I've had to do is I took these plans and I put them on I edited them so these were cylinders instead of the wonky shape that they were before, and it doesn't maybe have the best aesthetic because it doesn't come across from this top piece straight across to here anymore. It kind of dips down, which, okay,
it looks maybe not as good, but still looks pretty good. And it was easier to fabricate that way. Especially, if you have a rotary table, you can just, mill out these arcs. And so it makes it really easy. And possibly, if I was really thinking, I probably could have taken these and just cut the holes and put these on my lathe too, and just turned them as circles as well, using the hole with a mandrel. So that's another way to do this. But either way, I needed an arc. The other things that I've changed is in these uprights. These uprights just had a 3/4 inch hole drilled in them. And I have added some additional bushings in here with a grub screw that clamps down onto the shaft, the shaft in here. And the idea is that these prevent, or these bushings prevent the tube from getting squished, maintains its precision a little bit better. And also, these grub screws clamp down the shaft and they prevent the shaft from turning inside of here. And as you'll see here next, I've added bronze bushings in here. And I want the bronze bushings, the shaft to turn into the bronze bushings, not into the metal shaft. And let me zoom in here and I'll show you kind of some more detail on this. All right, so here in this detail, you can see I've added the bronze bushing here, and I've added bronze bushing to each of the 4 hinge plates that were described in the plans. And, I've welded these on just like, they say in the plans, but you can see here's the grub screw. I've tack welded the bushing in between this square tube into here, and that just holds it in place. You don't need a heavy weld in here for that. And then the bronze bushing, this is a user serviceable part. This is going to wear out before the shaft wears out or before the plate wears out. And so, over time, this is just going to wear better. This isn't a high wear thing. And possibly with the original design, you'd probably never wear it out. But the one thing I wanted was a super tight fit, and I wanted it to last. And to get that, you need some sort of bushing in here to make that happen. The other thing you'll notice is that I put this slot, this arced slot, I put it at the top. And there's a reason for that. Originally, it was down here at the bottom, and you had to put a hole in this square tube. And this isn't very thick square tube, at least for what I used. Probably could have got thicker stuff. But in Brian's plans, he threads it. And there is another plan out there called the Dictator Bandit. And they do the same thing, although they claim they use nuts and somehow it's better. I'm not sure. I haven't really looked into those plans. They look exactly like housemade.us and what Brian made. So somebody copied somebody. But I decided to take a different route. I decided to put this slot up here at the top. And the reason is because I want to put this bolt right here. And what I want to do is I want to put a protrusion here, or some kind of thing here that this bolt can go into that fits up flush with this mounting plate or this hinge plate surface, so I can get good friction here. And also, I do want to use a nut here because this is a high wear item. I can see myself wanting to rotate this a lot. And if I rotate this a lot, eventually I'm going to wear out the threads. So if I use a nut in here and somehow make it so the nut fits in there and that it can apply the appropriate amount of friction here to keep this plate or keep this hinge plate, up against another piece of metal and keep it tight, then I have a good chance of having a good tight fit. It won't prevent vibration. So the whole thing does rotate. It's a little bit, it's just about stiff enough, but it fits really tight. So that's how it rotates on this. And so this bolt here will go through a hole, and that nut that fell will then go into a piece of metal here, probably just slotted in and held in place. But the idea is that it will hold it so that you can tighten this down. And then I'll probably put, some kind of handle on here or something that allows this to function. Some other things that's worth noting, that these are a little bit smaller than the original dimension and radius wise. That's just because I decided to mill it after the fact, after I tried to, cut it out on my bandsaw, my Portaband. And then I tried to, sand it down as flat as I could, or to make this nice arc. And so I ended up having to take off quite a bit of material. But I think there's quite a bit of enough meat here, enough metal, that it's still going to be plenty strong. This is 1/2-inch plate steel. So, it's just mild steel, stuff you get from your local metal distributor. And then the shaft, it's a 5/8 inch shaft. I did mill or put this in my lathe and mill it down to the dimension of these bushings. So it's a super tight fit. Not everybody's going to have that. So I think you could easily use a 5/8 inch bolt. And then the other thing I'm going to do here is I'm just going to put some Loctite in here to hold these bushings in place, because you want the shaft to turn into bushings, not the bushings to turn inside the plate. So they don't right now, but I just want to make sure that everything is solid. So after a painting, I'll go ahead and, put those in, Loctite those in. All right. So the other thing is I use a square tube. This square tube, I'm not sure if I didn't get the right square tube or what, but I took the weld seam out of this, and my tooling arm still did not fit inside this square tube. And so I actually took the tooling arm and I milled it down to a precise dimension that fits inside this square tube. Now, square tube isn't very precise. Like, it's a really hard thing to get down to exact dimensions. And probably in hindsight, I probably would have got like some plate and just, made my own square box here, like in some other plans, and then milled this square tube down to more of an exact dimension that would have fit inside that plate, which would have been a lot more precise. But I didn't think that far ahead. And anyway, square tube is what I had a lot of, because most of this is made out of scrap that I've had just laying around. So I milled this arm so it fits in here. Not everybody has that ability to mill this. I maybe you could put this on like an angle grinder or something with a flapper disc and sand this, to dimension if you're careful. But I ended up milling this down to fit inside this tube. Is it cheating? Probably, but boy, this fits super tight in here. Put a little bit of oil on that, and that's going to move really, really smooth. And I still have to drill the hole here in the top for put friction on this arm and retain it in place. And then I still need to build this second tooling arm. This is actually for the rest. This is where the D plate will fit on this with the platen, and then the platen wheels. And then, so that's kind of some of the modifications I made to this. All right, this is the tensioner arm. In the original plans, they have a spring that goes back here. I'm going to drill a hole back here and move this arm forward, and I'm actually going to put a gas strut on there. Some of the other plans have gas struts on them. I don't know if it's any better or any worse. I would think that the gas strut just kind of looks nicer, looks a little less cheap. Maybe it's still equally as functional. But my point is that I'm going to move this forward, put a gas strut on it, and then this will get a handle on it so that you can operate the tensioning arm, take your belts off, put belts on, and then I still have to make the tensioner wheel alignment mechanism that will go here. Still thinking about whether to build or buy that. Same with the D plate, actually. I might buy that as well. I'm just kind of short on some time and I kind of want to get this up and going. So, yeah, so those are the changes, or the notable changes I've made to Brian's original plans. Those are things I thought were necessary. It kind of makes a little bit more quality product. Not that it wasn't quality before. It's such an amazing looking belt grinder. The hinge mechanism is amazing. Lots of innovation went into this. So I'm going to make my changes available to Brian. I'll send him my Fusion 360 files. And I don't want to take away from his hard work on this project. So but I will try to make these available for people to use. Okay. Anyway, that's all I got for now. Yeah, I'm in my garage. This is coming along. This has been a great project and I've really enjoyed putting this together.